On now. You could record. There you go. Oh my God. All right, it worked. Here we go. So we're recording and we're looking at this problem. All right, Madeline records the number of homework assignments she has and the total time it takes her to complete the homework. Her data is in the following scatter plot. Use a scatter plot for the problems 4 and 5. All right, find the equation of the line that is the best fit. This is giving everybody trouble because folks are afraid to make a mistake, and I'll just implore you, don't be afraid. Don't worry about it. You had to copy this down, so I hope that that was a successful part to it. And the next step is to go ahead and make your line of best fit. So here's the thing. When I'm looking at this, what? Oh no, the bad eraser. Dang it. We want to go right through as many points as we can and above and below as many as we can. You see how if I go like right here, it's not bad. But here's the thing. You could have decided that this is your line of best fit and make your case for it. You could have decided that this is your line of best fit and you'd make your case for it. Okay? The case for it is in the interpreting the slope and y-intercept. So it does not matter if you're perfect. How could you be perfect in choosing what your line of best fit is? It could be around there. I think that might work. And it also goes through 0, 0, which might make sense that if I've done 0 homework assignments, that I've gone and used 0 minutes. But even if you didn't have that, even if your line went through like here at 5, right? It's okay. You could just have to interpret it and make something else up, okay? All right, good. So yeah, if you're almost exact same thing, huh? Yeah. So some people's line, the original line when I did this homework problem before, it went through the y-intercept was like 5. It didn't go through 0, 0. So when I'm interpreting the y-intercept and it goes through 5, I might say, well, you know what? Before I started doing a homework assignment, I stared at the wall for 5 minutes. Or I stopped and watched some videos for 5 minutes. I procrastinated, right? So you're making up a story based on the graph. There's no wrong story as long as you elaborate it, okay? So look, we have the line of best fit. It's our line of best fit. We didn't use technology, so it's not perfect. But if we're trying to find the equation for it, I have to just recall that I know I'm going to use a linear equation. So the first step is to figure out what is my y-intercept. The y-intercept is 0 in this case. The hardest part, I think, for these, because it's easy to find where the y-intercept is. You look at the line, you go, where's the y-axis? Oh, there's the y-axis. Where does it intercept? Oh, it intercepts at 0, right? Finding the y-intercept isn't hard. It's just literally looking and seeing where it crosses the y-axis. But now we got to find the slope. That's the harder part, and that's where it's giving people trouble too. Because when I'm looking here, and nothing looks perfect. It doesn't go exactly through a line. It doesn't go exactly through one of my grid marks. That one's pretty close. But I could use, I'm going to use 0, 0 to find my slope. I'm making my steps, right? I'm making my steps to find my slope. So I'm going to use 0, 0. I think I'm going to use this point right here and just know that it's right below 20, right? It's not exactly at 20, right? It's not exactly at 20. So what I need to do is find out what is the rise, what is the run, right? It's just the rise and the run. That's all the slope is. Slope is just rise or the run. And if you're careful with your graphing, you don't need to use the slope formula. You can just literally count it. All right, I said that maybe this goes right below 20. So let's say maybe it goes up. It goes up plus 18. It goes up plus 18. So 18, here's my slope. And how far over does it go? From 0 to 1? Yeah, it goes over 1. Oh, yeah. So some people are saying, well, I got y is equal to 20x. So close, so close. That could have been slightly different with your line, right? It's just like it could have been a half a degree further over. And that would give you a slightly steeper, yeah, a slightly steeper line. And that's a good point. You're saying that you got 240. So your line went exactly through this point. You see how my line went just a little bit below it? That's like literally the difference. It's the difference between, as I'm putting this down, I do that. You did this instead of this. You see how close that is? It doesn't matter because we're not going for perfection. We'd use technology for perfection. We're just trying to get a line of best fit, and then we're going to make our interpretation. So our slope is 18x. So our equation is y is equal to 18x. Now you might be like, well, I got y is equal to 20x. That's fine. That's fine. Your line was slightly different than mine. Did anybody get another value for that? Y is equal to 20x. Who else got something? Anybody else get y is equal to something that's different? Y is equal to 20x, 18x. All right. So now we have to go and we have to interpret this. All right. Let's interpret the y-intercept, and then we'll interpret the slope. Now the y-intercept, b is equal to 0. Okay. And let's just see what this is saying. What is this whole thing saying? This is saying that at 0 minutes, I've done 0 assignments. Awesome. And then it says that it takes me 18 minutes to get through one assignment. 18 minutes to get through one assignment. 18 minutes, another assignment done, another assignment done, another assignment done. And you might say, well, wait a minute. Those data points aren't on the line. No, the data points aren't on the line. But when we're interpreting this line of best fit, we're looking at the line of best fit. And we're only looking at the line of best fit because it allows us to make projections. Yep. Correct, Melanie. Perfect. So let's go ahead and write this down. B is equal to 0 because, right? At 0 minutes, 0 assignments completed. You see, that's interpretation. B is equal to 0 because at 0 minutes, 0 assignments completed. I haven't done anything. I haven't even gotten out my books. At 0, it makes sense because there's no assignments done. Yeah, that's exactly what I put. Well, not exactly, but your interpretation, your words you use, the number of words is going to be different than mine. And what you wrote in the chat is perfect. Slope, m is equal to 18. And what we're saying here is it takes 18 minutes per one assignment. And if your line of best fit was a little different, you might have it where it's 20 minutes, it's 21 minutes, it's 17 minutes. But we just had to recall that it depends on the units, right? If this was, well, we won't say what it is, but look, this is saying a rise, number of minutes, rise, over run, number of assignments. So rise is 18 minutes per one assignment. Then we'd go up another 18 minutes for my second assignment, and so on. The projection of how long it would take is based on the line, and the slope says how much change has happened as we go through each assignment and how much time has taken place. So this is a matter of doing your best to find your best fit line. Finding the equation based on the y-intercept and the slope, which you can count visually, and then interpreting it. What does it mean that 0 is my y-intercept? What does it mean that my slope is 18? And that slope is probably the hardest, but the slope has to do with minutes per assignment. 18 minutes, right? 18 minutes per one assignment. You see? That is how we know what the slope is talking about. What the slope? So what the slope is talking about is you can think about it as the units. The rise is how many minutes change over the run, how many homework assignments you've done. And that reduces out, it tells you how much each homework assignment will take. All right. I'm gonna give you a moment to take a screenshot of that. I'm gonna go ahead and stop the video because we have time to just go over this one problem. All right, thanks.